Okay, let's go ahead with our second video, continuing with factoring. Okay, this is a nice short one. If you look at the first one that's on the paper, 4x squared minus 9, you'll notice it's missing that middle term. Okay, it's smaller than the other ones. So looking at this, there's nothing that you can't pull out. There's no number in common, there's no variable in common. Okay, so what you want to look at, kind of a hint when it's missing that middle term. If you look at that 4 and you look at that 9, you're going to notice that they are perfect squares. Okay, and what lets them miss that middle term or to have it cancel out is a factoring called a sum and difference. Okay, I know you've seen this. Okay, sum and difference is when you have two perfect squares at the front and at the back end. So you have a 2x here and a 2x here. That's going to create that 4x that we had up in the front, our leading coefficient. Okay, now we need two numbers in the back that are going to multiply and get that 9. Okay, and I know you already know it. You have a 3 and a 3. Now, I need to put a plus and a minus. That's where we get the name sum and difference. A sum and difference enables these that when they multiply through. So if I take the front terms, I get my 4x squared. Okay, my outside and my inside is what makes that middle term. So my outside, if I were to multiply, would be that 2x to that minus 3. So that's a negative 6x. Okay, my inside creates a plus 6x, and the last term is 3 times that negative 3, which is a minus 9. Okay, so now if you're looking at that, you should be able to see now at this point that those middle terms are going to cross off, and that's where we end up getting a 4x squared minus 9 back to where we started from, okay? And that's what enables that sum and difference is what enables that middle term to disappear, okay? All right, so when you have that middle term out of there, always look to see, do you have perfect squares that could make that sum and difference? Okay, welcome back. Let's do the next problem. Okay, looking at this one, I'm trying to see if there's anything I can pull out to reduce it. Okay, if I'm looking at all three terms, there's nothing in common. No number, no variable. Okay, I'm also going to look at this problem has a middle term, so I can rule out a sum and a difference. Okay, so look at the numbers that are within this problem. There is something that you happen to notice. If you look at the 16, the leading coefficient, and the last term, the 25, those happen to both be perfect squares. Okay, now I know it can't be a sum and a difference because there's this middle term here. Okay, and when there's a sum and difference, that middle term would be gone. Okay, so we can't use the sum and difference, but the fact that you have that middle term is telling, or that, the perfect squares is telling me maybe we should try something similar to that. Sorry about that. Okay, there we go. Sorry. Okay, so let's use our two sets of parentheses and see what we can do with this. Okay, so now that 16m squared, I'm going to try to see, because it's a perfect square, if I put a 4m in the front and another 4m over here, and looking at that last term, that 25n squared, what happens if I put a 5n and a 5n? Okay, now you don't know if this is going to work or not. There's no guarantee, but you try it. Okay, because it's definitely better than trying a slide and divide with such big numbers. Okay, so now you know that that middle term up top, that 40mn, okay, that 40mn is there due to the O and the I of the FOIL. Okay, the O and I of a FOIL, of the FOIL method, this part right here, the O and the I, comes from the outside and the inside when we multiply, okay? So if I multiply the O, which is the outside terms, and the inside terms on this one, all right, I would get a 20mn and another 20 mn. Okay, I need to create a negative 40 mn. So these two terms would have to both be a negative, okay? So that's telling me I need two minus signs between these. Okay, so now this has a special type of name. It's a special product, and they call this a square binomial. Now, it's a square binomial because we can take both of these and then rewrite it. Okay, so let me get some room here so we have a place to put this. Okay, because there are two identical factors, I can turn around and shorten this by writing 4m minus 5n to the second power. Okay, now if you factor it out and you left it this way, I'd be just fine with that. You don't necessarily have to shorten it and put it to the second power. Okay, that's it for this lesson. Thanks. We'll get ready for the next one.